Laser weapons are now occupying a substantial space in defense plans across the globe by providing an economical and effective substitute for missile interceptors. China officially debuted the LY-1, a massive shipborne laser air defense system. As a type of laser weapon, the LY-1 can also effectively avoid the problem of time lag between the target lock-on of shipborne fire control radar and the actual firing of traditional air defense weapons. It also effectively avoids the problem of a large dispersion ratio of traditional shipborne closing guns. The LY-1 can accomplish aiming equals locking on firing equals hitting with very high interception accuracy. China's Victory Day parade was an enthralling display of several cutting-edge weapon systems developed by the country as part of an extensive military modernization drive. Among them was the LY-1, touted as the world's most powerful laser-based air defense system. The event was hosted by China for the first time to mark the 80th anniversary of the victory in the Chinese People's War of Resistance against Japanese aggression. China officially debuted the LY-1, a massive shipborne laser air defense system. The system was part of a shipborne air defense formation that also included HHQ-9C, the HQ-16C, a close-range air defense system, a high-power directed energy weapon developed by China. The LY-1 is primarily designed for use aboard the People's Liberation Army, Navy, warships, and perhaps its aircraft carriers. However, as seen in the parade, the LY-1 features a turret-mounted design, which means that it could be adapted for ground use. In naval configurations, it may include a retractable protective dome to shield the system when not in use. Similar to prototypes tested on U.S. Navy ships, military affairs expert Zhang Ong told the state-owned publication Global Times that on ships, the LY-1 has sufficient space for power units, meaning that it could have higher power, allowing it to intercept not only unmanned systems, but also anti-ship missiles with very low cost for each interception. As a type of laser weapon, the LY-1 can also effectively avoid the problem of time lag between the target lock-on of shipborne fire control radar and the actual firing of traditional air defense weapons. It also effectively avoids the problem of a large dispersion ratio of traditional shipborne closing guns. The LY-1 can accomplish aiming equals locking on firing equals hitting with very high interception accuracy. This design would likely allow rugged deployment in combat environments, including at sea. It also suggests mobility, potentially enabling engagements while on the move in land-based setups. The overall size indicates a high power output, distinguishing it from lower power dazzling lasers that China has extensively deployed. Several PLA analysts noted that the debut of the system at the parade meant that it had already entered service or is about to be inducted soon. China has been working on developing laser-based air defense systems for several years and has made significant strides in the quest. For instance, it has developed the Silent Hunter, a 30 to 100 kilowatt electrically powered fiber optic laser weapon designed to neutralize low-lying drones, and the laser-based Chin-Nun counter-drone system. China's laser air defense system has allegedly been spotted in Iran and Russia. The LY-1 will further bolster China's anti-access area denial capabilities, particularly in contested regions like the South China Sea or Taiwan Strait, which will make a conflict with Beijing more expensive for the United States for. Additionally, the use of a laser air defense that costs a fraction of the cost of a surface-to-air missile will reduce the cost of downing hostile targets, especially since U.S. generals are working on the Hell's Cape strategy that involves the mass deployment of inexpensive autonomous, unmanned systems that will be used to attack the PLA in a conflict. The proliferation of low-cost drones, as seen in conflicts like Ukraine, has exposed vulnerabilities in traditional air defenses. Laser systems provide a sustainable countermeasure with their low per-shot cost. An unlimited magazine, the Chinese experts believe that the development of shipborne laser weapons will fundamentally alter the rules of maritime warfare, since they can successfully target the optical sensors of adversary weapons and equipment. Laser weapons are now occupying a substantial space in defense plans across the globe by providing an economical and effective substitute for missile interceptors. Lasers are particularly useful against unmanned aerial vehicles because their concentrated laser beams can rapidly heat a drone's body. This can result in the drone's structural failure, leading to the burning off of one of the wings on a fixed-wing drone. Laser weapons typically enhance naval defense against anti-ship missiles, small boats, and unmanned aerial vehicles at sea. Using these weapons significantly lowers the number of casualties because, unlike kinetic weapons, there is no momentum transfer shockwave or high-velocity fragments. Moreover, a high-energy laser beam's instantaneous time of flight prevents the target from making the first strike. The U.S. Navy's high-energy laser with integrated optical dazzler in surveillance. Helio system integrated into destroyers is a prime example of this. Developed by Lockheed Martin, it is a large stationary energy-producing apparatus with a directed energy array mounted on top. Some observers said that the Chinese LY-1 is likely very similar to the laser weapon programs pursued by the US, such as the Helios with directed energy weapons taking center stage. The United Kingdom has also developed a laser weapon named Drag-on-Fire, laser-directed energy weapon for installation aboard its warships. It is a 50-kilowatt class, laser-directed energy weapon designed to counter drones, missiles, and mortar rounds with high precision and low cost per shot. The system includes an electro-optical camera and a secondary lower-power laser for target acquisition and tracking mounted on a turret for precise aiming. The Drag-on-Fire weapon is accurate enough to strike a 1-pound coin from a distance of 1 kilometer, and the cost of operating the laser is typically less than 10 pounds per shot. Israel, on the other hand, has developed the Iron Beam, which is a 100 to 150 kilowatt solid-state fiber laser system capable of focusing a beam to the diameter of a coin at 10 kilometers. Russia has also developed multiple laser weapons that remain classified so far. This includes Pervet, and ZA Pervet is a ground-based laser weapon system named after Alexander Pervet, a medieval Russian warrior monk. It is designed for air defense and anti-satellite warfare, primarily to dazzle or blind optical electronic reconnaissance satellites, and protect mobile intercontinental ballistic missile launchers. On the other hand, ZADI is an advanced laser weapon system designed for thermal destruction of targets, particularly drones rather than just dazzling. Its power is believed to be in the 50 to 100 kilowatt range. Asian military powers, such as the Republic of Korea and India, have also developed their own laser weapons. South Korea's Star Wars project aims to transform defense capabilities with laser weapons designed to neutralize drones and missiles.